Welcome back to Daily Dose of Space. Today, we're diving into one of the most fascinating discoveries of the year, one that tells a quiet, almost melancholic story about the cosmos itself. The European Space Agency's Euclid telescope has confirmed that the universe has already passed its era of greatest creation. The age when galaxies were bursting with new stars, billions of suns forming every second across the cosmos, is long behind us. From now on, space will only grow colder, darker, and quieter. But how do we know this? What did Euclid see that previous telescopes missed? And what does it really mean for the future of the universe? And for us? Let's explore the mission that looks back in time. Euclid is one of the most ambitious missions ever launched by the European Space Agency. Named after the ancient Greek mathematician, it's designed not just to take beautiful pictures, but to map the geometry of the universe, to understand how matter, energy, and gravity have shaped its structure over billions of years. Launched in 2023, Euclid orbits at the L2 Lagrange point, about 1.5 million kilometers from Earth, sharing the same quiet region of space as NASA's James Webb Space Telescope. While Webb focuses on specific targets in incredible detail, Euclid's job is to look at everything. It's performing an enormous cosmic survey, covering 1/3 of the entire sky, to build a 3D map of galaxies and dark matter across cosmic time. This mission is designed to answer one of the biggest questions in modern cosmology. How is the universe expanding, and how does dark energy influence that expansion? But along the way, Euclid has given us something unexpected. A detailed look at how galaxies evolve and how the cosmic furnace of star formation has cooled down over billions of years. The Golden Age of Star Formation. To understand Euclid's discovery, we need to go back around 10 billion years to what astronomers call the cosmic noon. It was a time when galaxies were at their most productive. Giant clouds of hydrogen and helium collapsed under gravity, igniting into countless stars. Everywhere across the sky, young galaxies glowed blue from newborn suns. The universe was alive with light, a cosmic festival of creation. But even back then, that golden age was temporary. The raw materials for new stars, hydrogen gas, were being used up. As galaxies grew older, they consumed their fuel and expelled much of it into space through supernovae and black hole jets. The universe, in a sense, was burning through its youth. How Euclid measured the slowdown. Euclid's wide-field infrared and visible cameras allowed scientists to observe galaxies at different distances, and therefore at different times in history. By comparing galaxies close to us with those billions of light years away, astronomers can literally watch how star formation changed over time. The new data shows that the rate of star formation peaked roughly 11 billion years ago, and since then, it has declined by more than a factor of 10. Today, only a small fraction of galaxies are actively forming stars, and most of them do so very slowly. In other words, we're living in a cosmic retirement era. The Euclid data doesn't just confirm what earlier telescopes suggested, it refines it. For the first time, astronomers can map this decline with unprecedented accuracy across vast regions of the sky, showing exactly how galaxies went from wild, chaotic birthplaces to quiet, mature systems like our own Milky Way. Why the universe is cooling. The decline of star formation has everything to do with energy, or rather, the lack of it. Stars form when cold clouds of hydrogen collapse under gravity, but that process needs a delicate balance between pressure, gravity, and cooling. Over time, galaxies lose the gas they need. Some of it is locked up in old stars, some is blown away by black hole winds, and some is simply heated so much that it can no longer condense. Massive galaxies are especially prone to this. Their central black holes release powerful jets that heat the surrounding gas, preventing new stars from forming. On a cosmic scale, that means the overall temperature of interstellar space is falling. There's less ultraviolet light, fewer supernovae, and fewer energetic events. The cosmos is dimming. What it means for the future. If this trend continues, and Euclid's data strongly suggests it will, the universe will become increasingly quiet over the next tens of billions of years. Existing stars will age and die. New stars will still form, but more slowly and mostly in small galaxies or in isolated regions. Eventually, the great spiral galaxies will fade into reddish, ghost-like remnants, populated by long-lived, dim stars, the cosmic equivalent of embers after a great fire. Far into the future, when the last hydrogen has been fused and the last white dwarfs have cooled, the universe will enter what physicists call the degenerate era, a time dominated not by light, but by dark matter, black holes, and the faint afterglow of ancient starlight. It sounds poetic, but it's simply the natural outcome of physics. Humanity's perspective. For us, this discovery is a reminder of scale and time. Everything we see today, every shining galaxy in the night sky, represents a brief window in an unimaginably long story. Our solar system, born around 4.6 billion years ago, formed well after the cosmic peak of star creation. We are, in a sense, latecomers to the party, living in a mature, stable universe that's slowly winding down. Yet, this stability is also what made life possible. The quieting cosmos gave stars like the Sun time to form planets, and for those planets to evolve complex chemistry and biology. The same cosmic calm that signals the end of an era also gave rise to us, beings capable of looking back and understanding it. Euclid's continuing mission. Euclid's first year of data is just the beginning. Over the next 6 years, it will chart billions of galaxies, mapping their shapes, distances, and movement. This data won't just refine our understanding of dark energy, it will also help us trace the life cycles of galaxies with unmatched precision. Combined with observations from the James Webb Space Telescope and future missions like the Nancy Grace Roman Telescope, we're entering an era where we can watch the universe grow old in detail. Every faint galaxy Euclid photographs is a snapshot of the universe at a different age, a frame in the longest time lapse ever made. Conclusion: a universe that remembers. Euclid's discovery doesn't mark the end of something. It marks a deeper understanding of how the cosmos evolves. Stars are still being born. Galaxies are still forming. The universe hasn't gone silent yet. But now we know. The cosmic fireworks of its youth are behind us. We are witnessing the afterglow of creation. And perhaps, in understanding it, we appreciate our own place in it just a little more. Because in the grand timeline of the universe, even as the stars fade, the story continues, written in light, matter, and time itself.